Hello everyone, welcome back. In this video, we are going to look at today's LeetCode daily challenge, and the name of the problem is keys and rooms. So in this problem, we are given n rooms labeled from 0 to n minus 1, and all the rooms are locked except for room 0. Okay, so in the beginning, we can only visit room 0, and our goal is to visit all the rooms. However, we cannot enter a locked room without having its key. So, and it is given that when we visit a room, we may find a set of distinct keys in it. Okay, so when we visit a room, we may find a set of distinct keys in it. Each key has a number on it, denoting which room it can unlock. So we can use those keys to unlock other rooms. Okay. So we'll be given an array rooms where rooms I is the set of keys that we can obtain if we visit room I, and we need to return true if we can visit all the rooms, or else we are going to return false. So this was the problem statement, and let us now see the approach to solve this problem. So in order to solve this problem, we are going to use depth first search. So DFS is basically a recursive approach in which we basically go deeper unless we come across a node which is already visited. Okay, and then we visit another branch, and we do the same thing. We go deeper unless we come across a node which is already visited. Now in this problem, we can also use DFS, but I'll be solving this using depth first search. How DFS is going to work in this problem is that it is given that the first room is unlocked. It means that we can visit that room, and whatever set of keys we find, we can use those keys to visit other rooms. Okay. So starting with this, we are going to enter our DFS function. We are going to mark our 0 room as visited, and then we are going to one by one take all the keys present in the 0 room, in the 0th room, and then we are going to visit those rooms. And so basically how it's going to work, let's see this. Then we are going to discuss this example also. So let us say I am at room X, and from here I found some key. I found some key A, B, and C. I'm starting from room X, and after visiting this room, I found these keys. So firstly, I will go to room which can be opened using key A. So I go to room A. Now here also, I will, as in DFS approach, we go deeper. So firstly, I will explore the entire branch. I will not backtrack, but instead I will continue the process. I will again check what keys can be found at room A. So let's say at room A I found key D and E. So then after visiting room A, I found 2 keys of room D and E. So firstly I will visit room D, and here I found no key. So I will backtrack, and then I will visit the another room which can be opened using key E. So again I will backtrack, as here also I found no key. I will backtrack. Or let's say at room E I found key A, but as room A is already visited, there is no need to visit it again. So we will backtrack and we will come back at room X. Now another key that we found at room X was key B, and as this room is unvisited, we are going to visit this. and let's say here I found key C. So as it is a DFS approach, we are going to continue and we are going to go to room C as well, as we are having its key and it is unvisited, so we will go to room C also. And now at room C we found no key, but it is visited, so we will backtrack and again we will backtrack to room X. Now we are done with room B. So next key that we are having at room X is key C, key of room C. But as we have already visited room C, we are not going to go there again. Okay, so this is how DFS basically works. If we are visiting a particular node, then we are going to go deeper in its subtree, and then we are going to explore its other branches. Okay, so now let us see this example which was given to us in the problem statement. Okay, so as the first room is unlocked, it means that we can visit that room. So we are going to start our DFS from the 0th room. So okay, so in the 0th room we are having keys of room 1 and 3. So firstly we are going to mark room 0 as visited. Now we are having keys of room 1, so we are firstly going to visit room 1. We mark it as visited. We are at room 1. As it is DFS, we are going to continue instead of backtracking. So at room 1 we are having keys 3, 0 and 1. So firstly we are going to take the key of room 3, I'm sorry. So firstly we are going to grab the keys of room 3 and we are going to visit this room. So room 3 is also visited. So now currently we are at room 3. At room 3 we are having key of room 0. But as room 0 is already visited, so from room 3 from room 3 we can also visit room 0 as it is having key of room 0, but room 0 is already visited as it was already unlocked, so we are not going to visit it again. Okay, so from here we are going to backtrack to room 1 again. Now at room 1 the next key that we are having is of room 0, but as I said, room 0 is already visited, so we are not going to visit it again. But I should present it here that room 0 can also be visited from room 1. Now the next key that we are having at room 1 is of room 1 only, as we are already currently at room 1, so we don't need to visit it again. So we will do nothing and we will backtrack at room 0. We will backtrack to room 0. Now here next key that we are having is of room 3, but as we have already visited room 3, we are not going to visit it again, and then we are going to come back. So here our process will end, as there are no more rooms connected and we cannot visit any other room. And after this we are going to basically maintain a visited array where we are going to keep track of all the rooms which are visited and all the rooms that are not visited. So whichever room, if all the rooms are visited, we are going to return true, else we are going to return false. In this example we can see that room 2 here is unvisited, as no other room was having the key to this room, hence it is unvisited, and because of that we are going to return false. Okay, so this was the approach to solve this problem. Now let us see the code here. So this is the code. Firstly we are given our 2D vector array rooms. So firstly I am finding the size of the given rooms array, which will tell us the number of rooms. Then accordingly, I have initialized a visited array and initialized all the indices to -1. So currently we are saying that all the rooms are unvisited, and this visited array will help us to determine whether all the rooms are visited or not after our DFS function. So then here we are calling our DFS function starting from the 0th room, because it is saying that the 0 room is already unlocked, so we can visit that. All the other rooms are locked, and here we are passing our rooms vector and along with visited vector. Now in our DFS function, we are first whichever room we are currently at, we are marking it as visited, and then we are going to one by one take all the keys that are present in that particular room. So one by one we are going to consider that key, and we are going to check if the room of that key is unvisited, then we are going to make a DFS function call to that room. Okay, but if that room is already visited, then we are going to not make a call to our DFS function. So this is basically a simple DFS function, and after we are done with this DFS process, we are going to iterate through our visited array, and if any particular index is marked as -1, it means that that room was unvisited, and then we are going to return then we are going to return false. If all the rooms were visited, then we are going to return true. So this is a very simple approach. Let us try to submit this. So as you can see, this solution got accepted. So I hope it was clear. The time complexity of this solution is big O of n plus e. Time complexity is big O of n plus e, where n is the number of rooms and e is the total number of keys. Okay, so this is the time complexity, and if I talk about space complexity, then it is also big O of n, because we have initialized our visited array, which is of size n. Okay, so this was it for this video. Thank you and have a nice day.